negations. So we've seen this word proposition before, right? In the word proposition, you have the word propose. And basically, they're just statements that make a claim that may either be true or false. Okay. Every proposition must have the structure of a complete sentence, and it must also make a distinct assertion or a denial. So it's really important that it's a complete sentence and not, an incomplete thought. Okay. So, an example of a proposition could be North America is in the northern hemisphere, right? That's a proposition. It's a complete statement, and it also makes a distinct assertion. You could say Florida is in the south of the United States. That's a proposition. It's a complete sentence, and it makes a distinct assertion. You could, if you said something like, when it rains, it pours. Okay, that is a complete sentence, and it makes a distinct assertion. But if you have a sentence that's not complete or an idea that's not complete, then it's not a true proposition. Now, what we can do with propositions is we can negate them. So we call these negations or opposites. There's a symbol for negation. It looks like this little tilde or squiggle. Some books use different symbols, but that's the notation that we're going to use for negation. So a negation is just a logical opposite of a proposition. Okay, let me give you an example. So let's say I said to you, Joe is sitting in a chair. Okay, that's a proposition. It's a complete statement. It could be a fact or it might not be. Okay. Now, if I want to negate that, it needs to be the logical opposite. So let's say Joe is sitting in a chair. Okay, let's say that's true. If I negate it, it should have the logical opposite of that, which the opposite of true would be false. So how would I negate something like that? I would just say something like Joe is not sitting in a chair. So this statement right here, we would just call P. And if I negate it, I would use the symbol here and for not. So I would have squiggle or tilde, not P. So if P is Joe is sitting in a chair, then squiggle P or tilde T, P is Joe is not sitting in a chair. It's the complete opposite. One of the things that we can do with propositions is we can create what's called a truth table. And it's just a table with a row for each possible set of truth values for the propositions being considered. Okay, when we say truth values, we just mean true or false. So we'll just use T for true and F for false in our table. Okay, here's a statement. Amanda is the fastest runner on the team. We want to find the negation of that proposition, and if it's false, is Amanda really the fastest runner on the team? So if I want to negate Amanda is the fastest runner on the team, how would I make that the opposite of what the statement is saying? We would just put the word not in there. So we would say Amanda is not the fastest runner on the team. Okay, now if Amanda is the fastest runner, then that would mean that if she's not the fastest runner, if the negation is actually false, then the original statement must be true, right? So in other words, if this statement's false, the original statement is true. So the way you would set up a truth table is something like this. You'd have P, which would stand for Amanda is the fastest runner on the team. And then you would have not P, which is the negation. So in other words, if P was true, then the negation would be false. Here's another example. So after reviewing data showing an association between low-level radiation and cancer among older workers at the Oak Ridge National Laboratory, a health scientist from the University of North Carolina was asked about the possibility of a similar association among younger workers at another national laboratory. He was quoted in the Boulder Daily Camera as saying, "My opinion is that it's unlikely that there is no association." Does the scientist think there is an association between low-level radiation and cancer among younger workers? So if you read that statement very carefully, they have this word unlikely, and then they also say no association. So that's a double negative, right? Both have a negative connotation. In English, a double negative always turns into a positive. Okay, so if we think of it like this, let's make P equal, it's likely there is an association. Now notice I made it positive, right? Because my original statement says it's unlikely there's no association. Anytime you write out your original statement, you always want to make it positive. Okay, now this is where the tilde comes in. So now I've got, okay, how would I negate that? Well, if the statement says it's likely there's an association, then the negation of that would be that it's not likely or unlikely, right? Both mean the same thing. There is an association. Okay, now notice they say no association, right? Which actually transforms this back into the original statement, right? It's unlikely that there is no association because it's a double negative. So it's kind of like you start out with the positive, it turns negative, but then you have another negative. So two negatives turn positive. So now it's going to just basically say, you know, your double negative, it's not likely that there is no association. So what that means, and that little triangular dot things mean, therefore, you'll see that a lot in this chapter. Therefore, scientists believe it's likely there is an association. You know, anytime you have two negatives, they cancel each other out. So really, you don't need the unlikely and the no. You could just say, my opinion is that it's likely there is an association. right? The and the no part cancel each other and just make it positive. Here's a couple problems I'd like for you to try on your own, and all you're doing is determining whether the statements are propositions. So remember, they need to be a complete sentence, and they need to assert or deny something, and then give an explanation for why you think that. Here's another check your understanding that I would like you to try, which is you need to write the negation and then state the truth value of the original proposition and its negation, like we did here. So the original truth value is true and the truth value of the negation is false. And for the last check your understanding, you're going to explain the meaning of the given statement, which contains a multiple negation, and then answer the question that follows. So a multiple negation is like a double negative, right? It's multiple negatives. It doesn't even just have to be two, it could be more than that. But you want to analyze that for the actual meaning. And then when you're finished that, let's talk about logical connectors. So when we have propositions, right, statements that are made, complete sentences that are made, sometimes you'll see the words and or even if then, and those statements join the propositions together. We call those logical connectors, and each of them is treated differently. So and or if then are your logical connectors, and they join propositions. Okay, so you can say something like, one proposition could be, I go to the beach, and then you have another proposition that says, I swim in the ocean. So you could say, I go to the beach and I swim in the ocean, right? The word and connects those two propositions, I go to the beach, swim in the ocean, together. We call and statements conjunctions. And given two propositions, let's call them P and Q. Remember, they're just two statements that are being made. P represents one of them, like I go to the beach, and then the other statement is Q, I swim in the ocean. Okay, so the statement, if you were to say P and Q, we just call that a conjunction. And the way we would write it is we would write P, and the symbol for and looks like an arrow, kind of, Q. And statements are true if and only if P and Q are both true. So in other words, if I said to you, I go to the beach and I swim in the ocean, okay, that's a true statement. As long as I go to the beach and I also swim in the ocean. If I was to say to you, I go to the beach and I don't swim in the ocean, right, then that would be a false statement, because in order for it to be true overall, I have to go to the beach and I have to swim in the ocean. So both P and Q, both statements have to be true for the overall statement to be true. Another example would be, the capital of Florida is Tallahassee, and the capital of the United States is Washington, D.C. So since both of those propositions are true, the overall statement is true. So let's evaluate the truth value of these statements. The capital of France is Paris, and Antarctica is cold. Okay, so this part here is going to be P, the capital of France is Paris, and here's Q. And if we were to write that in logical statement, it would be P with the arrow Q. That just says the capital of France is Paris and Antarctica is cold. So the capital of France is Paris. That is true. And the capital of Antarctica is cold. That's true. So since they're both true, that means that overall the whole statement has to be true. Here's another statement. The capital of France is Paris. Okay, we'll call that P. And then we've got the word and. The capital of America is Madrid. Okay, that's Q. So again, we would write that as P with an arrow Q if we were writing things symbolically in logic. Well, I know the capital of France is Paris, but the capital of America is not Madrid. That's false, right? So this overall statement then has to be false, because in order for ands to be true, both P and Q, all parts, have to be true. Suppose you're given three individual propositions, like P, Q, and R. What we're going to do is make a truth table for the conjunction P and Q and R, and under what circumstances is the conjunction true. All right, so let's think about this. If I have a statement, right, just one statement, P, I know it could be true or false. If I have two statements, P and Q, there's actually four different combinations for the truth values of those statements. So it could be true and false, false and true, false and false. But now you have three statements, right? So I need to think about the combination of all three statements. So I'm going to make a little table, we call it a truth table, to kind of lay out what all of those statements would look like. So there's this first case where all three statements can be true, okay? But then I know all statements could be false also. And then a mixture. So like P could be true and Q and R could both be false. Or P could be false, Q could be false, and R could be true. So there's all these combinations, and we want to make sure we capture all of them. So if there's three different propositions being made, there's going to be 8 different possibilities. Okay? And the way I know that, there's kind of a pattern. So when you have one proposition, you know that there's just it's either going to be true or false, right? So there's 2 different statements, but there's one case. Let's say I've got P and Q. I know that there's going to be 4 statements, and I'm going to change this back to 2. Right? You could have both statements be true. You could have the first statement be true and then the next one be false, or it could be false true or false false. So there's actually 4 cases. So there's a pattern. It's 2 to the first, 2 to the second, which is 4. So now it's 2 to the third, which is 8. So there's actually going to be 8 different scenarios when you're dealing with P, Q, and R. Okay, so there's got to be a pattern to how we fill this table in. You could be here all day trying to fill in the trues and falses and make sure you get every combination. So what I do is I just write the first column. I make half true and half false. And then for the second column, I alternate. So I do true, false, and so on. And then for the last column, I do doubles. So I do true, true, false, false, and then repeat. Now you've got every combination of truth value for each statement. So you could have all statements be true, all statements be false, or a mixture of all of them. Now, the other thing to note is that you can interchange these columns. So they don't have to be written the same exact order. You'll still end up with the same answers. So the last column, we call it our answer column. It's P and Q and R. And remember that in order for that to be true, right, an and means all parts have to be true. So there's only one instance where all parts are true. So that means that if you were to make a sentence and have 3 different propositions connected with the word and, that all of those, the only time that that statement would be true is if all 3 propositions were true. So the rest of these are all going to be false. Because the word and implies both things have to happen for it to be true. I'm going to have you try the next part on your own. Here you're stating the P and the Q and give their truth values, and then determine whether the conjunction, the and statement, is true or false, and explain why. And then in the next one, you're going to make a truth table, this time for P, Q, R, and S. And you want to discuss when would that be true. Let's look at OR statements. So there's two types of ORs. We have an inclusive OR and an exclusive OR. So an inclusive OR means either or both. Okay, an example could be something like, let's say you have a health insurance policy and it covers hospitalization in cases of illness or injury. That means you could have an illness and your hospitalization will be covered, or you could have an injury and it will be covered. So it could be, or it could be both. So one or the other or both. Okay, and by the way, inclusive OR is what we're going to assume we're using in this unit. So unless it's stated otherwise, always assume that we're using an inclusive OR. An exclusive OR means one or the other, but not both. So an example could be you go out to a restaurant and they offer you a choice of soup or salad. It's one or the other, it's not both. And again, we're going to assume that we're using an inclusive OR, which means either one or both in this book. Okay, there's a problem for you to think about. So a little bit about OR statements. They are known as disjunctions. And let's say we're given two propositions. We'll call them P and Q again. The statement P or Q is known as a disjunction. And we would write it like this. So P and then or looks like an well, it actually just looks like a V. I was going to say an upside down arrow, but you could use the letter V. So that's P or Q. Okay, and it's true if either or both propositions are true, right? Because we're using the inclusive or. So it's not like an and, where an and both propositions have to be true for it to be true overall. So in other words, if you were to look at a truth table, you have two statements, P and Q, and P and Q could both be true, P and Q could both be false, or you can have a combination. P could be true and Q could be false, or P could be false and Q could be true. So if I want to find the truth value of a statement with the word or, and there's two propositions, I know that as long as there's at least one true, as long as one or both of the propositions are true, the overall truth value is true. So P and Q are both true there, P is true there, Q is true there, and since P and Q are both false there, the overall statement is false. Because for an or to occur, one of the propositions or both has to be true, because it means one or the other or both. So here's an example. There's a statement. We have to figure out, is it true? It says airplanes can fly or cows can read. Okay, so I know that this first part here is going to be P, airplanes can fly, and then Q is going to be cows can read. So is this true? So we've got P or Q. So I know airplanes can fly, that's true, right? As far as I know, cows can't read, so that's false. So as long as one of them's true, then overall the whole statement is going to be true. So that statement is true because airplanes can fly. So one of those statements is true. Okay? It doesn't matter that the other one is false. In this next part, what you have to do is make a truth table for the statements that are there. And then in this next part, you're going to state P and Q and give their truth value and then determine whether the disjunction is true or false and explain why. So just like what we just did. The last connector we're going to look at here is an if-then statement. Okay, we call these conditional propositions. They're also known as implications. So I'm sure you've heard of the word imply, right? Like A implies B. If this happens, then we can assume this will happen, right? And if then is, they propose something to be true, the then part, on the condition that something else is true, the if part. And that's something to be true that they talk about is the then part on the condition something else is true. And that something else is the if part. So like for instance, if you clean your room, then you can go outside. So we assume that the outside part, that you can go out as long as you clean your room. That's the condition that has to be completed first, right? So that's why we call them conditional propositions. Every conditional statement has a hypothesis. It's also known as the antecedent. So the prefix ante means before, right? And it's also made up of the conclusion, which we call the consequent. So think of it like this. If P, so whatever statement you want to fill in there for P, then Q. The way we would write that in symbols is we would use an arrow. So that means if P, then Q. P is the hypothesis. Q is the conclusion. So here's another example. If you get an A, then I will buy you a car. So how do I know what the truth value of an if-then statement is? Let's make a little table. So we've got two statements, P and Q, and we already know how to fill this out. Both could be true. You could have true and false, false and true, or false and false. And then I've got my answer column, if P, then Q. So an if-then statement is false only when you have broken your promise. Okay, so what I mean by that is, let's pretend you got an A and that I did buy you a car. Both of those are true. Then that statement is true overall. But if you do get an A, right, true, and it's false that I'll buy you a car, then I didn't keep up with my end of the deal. I broke my promise. So that's false. All the other ones are going to be true. So the only time an if then is false is if the hypothesis is true and the consequent is false, right? So it goes true, false, because I broke my promise. So an if then is, let's say, false only when you have broken your promise. Okay, think of it like that. Here's an example. We want to evaluate the truth of the statement. If 2 plus 2 equals 5, then 3 plus 3 equals 4. So here we've got P is going to be 2 plus 2 equals 5, okay, which we know is false. And Q is 3 plus 3 equals 4, which we also know is false. So what would the overall truth value be? Well, I haven't broken my promise, right? 2 plus 2 is not 5, so therefore 3 plus 3 does not have to equal 4, which we know it doesn't. So therefore, that the whole statement is true. There can be alternate phrasings for conditionals. You could see instead of if then, they could say something like P is sufficient for Q. Q is necessary for P. P will lead to Q. Q if P. P implies Q. And Q whenever P. So these are just different phrases that are still conditional statements, but they're not using the words if and then. So let's take a look at them. Okay, we want to recast the following statement in the form if P then Q. Okay, so here's your statement. A rise in sea level will devastate Florida. So if you take a look at the alternate phrasings, which one do you think does it sound similar to? If you said P will lead to Q, you are correct. So here's P, right? A rise in sea level, and then will devastate Florida. It's talking about like will lead to devastation in Florida. So this part is your Q. So I would just rewrite this as if the sea level rises, then Florida will be devastated. Didn't spell that right. Okay, and you can try the next two on your own. So you're going to rewrite it using an if-then. Those two statements there use the alternate phrasing of conditionals. And that's pretty much it for this section. Feel free to reach out to me if you have any questions or you need help. Have a great day, everyone.